Hi everyone, welcome to week 12 of machine learning. This week we're going to be looking at unsupervised learning when we have no labels but plenty of data. What can we do then? Well, we can do clustering for a start, and we can find out how to iteratively do this through the expectation maximization framework. We'll see how this works shortly. Shall we get started? Last week we touched on decision tree learning, a powerful machine learning algorithm that mirrors human intuition by looking at one attribute at a time. We saw that it's very expressive. It can overfit the dataset very easily by constructing a path in the decision tree to a particular set of attribute values, and then setting the leaf of that path in the tree to the y value for that particular example. And because of this, we need to prune the decision tree in order to combat variance. Otherwise, we'll exactly capture the input data, capturing not only the signal, but also the particularities of the dataset. In the post lectures, we saw that diversity is a very good thing, and we saw how to deal with that in the context of decision trees when we're looking at ensembling. We saw that bootstrap and bagging were ways of generating a new dataset, and that we sample with replacement to generate a new dataset where some of the examples are repeated and some are omitted. With each of the different datasets, we train a new classifier HT and apply uniform voting to get an answer for that particular training example. This helps to lower the variance of the classifier ensemble by averaging over many different datasets. We saw we can also adaptively build these data sets and then get to a notion of weighted voting by reweighting the data set at each iteration to account for examples that were either to downweight ones that were easy and to upweight those which previous iterations got wrong. Again, here we can help improve our generalization by using a simple hypothesis class like a decision stump. And finally, we looked at random forests. This was a method to combine bagging with decision tree learning, but also introducing another randomization process of feature projection to be able to capture even more variation. Here the idea is to tune each of the particular hypothesis that's generated in the ensemble method to some subset of the features. So let's take a look at what we're going to learn this week. This week we're going to be focusing on unsupervised learning. And so after having a basic understanding of unsupervised learning, we're going to be looking at two particular unsupervised learning algorithms for doing dimensionality reduction, which we're going to cover in the pre-lecture, and clustering, which we're going to cover in the post-lecture. We're going to implement and understand k-means clustering as a way of doing things in the in-class and post-class section, and understand the expectation or EM meta-algorithm for doing this type of optimization. In the in-class session, we're going to be looking at applying unsupervised learning on a real-world dataset.